Good afternoon. Right, let's try again. Good afternoon. All right. Well, if I say I'm jet lagged, I can claim it because I literally came from California yesterday. You guys are like, hopefully, mostly in the similar time zone. Say again? Of course. My name is Arun Gupta, and I work for Couchbase. This talk is going to be about how do you migrate your traditional VM-based cluster into different container framework. This is based upon my experience and how we have helped our customers migrate their Couchbase clusters running in a very traditional, classical Amazon scenario into 4 different frameworks. That is, we'll talk about Docker Swarm, particularly Docker for AWS. We'll talk about Kubernetes, we'll talk about Red Hat OpenShift, and we'll talk about Mesos and DCIOS. So I'll show you clear ways on how we migrated a Couchbase cluster running on Amazon to all of these different 4 frameworks. So hopefully you'll pick up bits and nuggets. First of all, what are the concerns that are around migrating these cluster from VM to a container-based framework? What is it that you need to be worried about? And more importantly, what is the exact recipe that we use to migrate them? A bit about myself. I also run the DevOps for Kids chapter back in the US. I founded that nonprofit in there. I truly believe we should educate our next generation. As part of that, my son and I authored a book, Minecraft Modding with Forge, which your kid's first Java lesson could be making a bigger TNT explosion. It doesn't have to be public static wide main. This is, I think of, when I think of virtual machine, I think of a house. If you think of a house, there is certain notion about it. It'll have a bathroom, it'll have a kitchen, it'll have a couple of bedrooms, it'll have a guest room, it'll have a garage, it'll have its own heating, electrical, plumbing, the whole thing of its own. It helps you protect it from unwanted guests. So it has a door outside, so you can put a lock on it and things like that. That's sort of a typical normal house. It has its own front yard, backyard. So no matter what you do, even if there is one person living in it, there is a fixed cost associated with it, to run the house. Think of an apartment. Now, in an apartment building, the apartment building is bigger. You could have a studio apartment. You could have a penthouse in the same apartment based upon your capacity. Today I'm working for a tiny company. Tomorrow I start working like Larry Ellison. Maybe I'll buy the apartment building or I'll live in a penthouse. So, depending upon your ability and capacity, you can live in an apartment, the level of apartment. The apartment has shared electrical, shared plumbing, shared all of that. You just draw from part of it, and then you leverage that, and then you pay the money for it, or you pay the cost for it. So that's sort of how you look at it. And again, if you look at the similarity from the house itself, apartment building has a gate, and then after the apartment building, your apartment has a gate as well. So they both provide unwanted guests. They both prevent any unwanted guests coming into your property. So if I take that house and apartment kind of analogy, let's see what sort of the similarity and the dissimilarities between virtual machine and containers. Well, first of all, they're both designed to provide isolated environment to run your application. In the sense, if you're running your application in a virtual machine, this is completely isolated from other. It has its own networking stack, its own storage, own volumes, etc. And similarly, in the containers, it's a little bit smaller version of it, but everything is kind of within that environment itself. But you can run fairly isolated when you're running an application in a container environment. In both cases, whether it's a container or it's a virtual machine, they are both binary artifacts. So you can take a virtual machine, put it from one host to another host. Similarly, a container, you're running it in one host and you can take it to another host. All the dependencies could be packaged in there. Now, if there are services running and those are linked from each other, then you bring the entire application along with. But the idea is, it's a binary artifact that can be transported from one host to another host. We talked about how virtual machines are more like houses, where there is a fixed cost associated with them. There is time associated with them to build the house or to start the virtual machine, typically in a matter of few seconds, double-digit seconds actually, as a matter of fact. And if I look at the apartments, then those are more like containers. if you think about the building, it's more like Docker host. And if you think about the leasing office, it's more like a scheduler. So when you want to rent an apartment, you go to the leasing office, say, here are my requirements, here is what I want to do. The leasing office will find the right fit for you and then say, you know what, okay, you are scheduled in this particular apartment. You can live there as long as you want. When you're done, you want to upgrade, downgrade, whatever you want to do. I'm the leasing office, I'll take care of it. So that's your container scheduler, so to say. Another fundamental difference between virtual machine and containers is with virtual machine, you get this blah operating system and you start scooping out the things that you don't need. So you start removing it. With containers, it's the other way around. You get this minimal operating system image, and to that operating system, you add what you want. So if I compare and contrast, as a matter of fact, Ubuntu ISO, if you want to build an Ubuntu VM, that's about 1 gigabyte, just the ISO download. Ubuntu Docker image, if I look at it, is more about 123 megabytes. And then depending upon where you start with, what's your base image, you can start adding and figure out, how big or how bulky it needs to be. So that's just a basic comparison between virtual machine and containers. There are lots of good studies, lots of good differences, similarities, analogies between virtual machine and containers, but that's sort of what is relevant from our perspective that we need to know today at least. Now, a huge shout out to docs.docker.com. Anytime I think about I need help, I go to docs.docker.com, and typically I find a good image or a good and very nicely, clearly explained language over there. This is a diagram from Docker Docs itself. So on the left-hand side, what you see is, for example, how a typical virtual machine architecture would look like. You have an infrastructure, public cloud, private cloud, on-prem, laptop, whatever it is. On top of that, you have your operating system running. It's a host operating system because it's a host to a guest. You have a host operating system running. On top of that, you could be running a type 2 hypervisor. In certain cases, you may not have a host operating system. You may be just running a bare metal hypervisor. But you have a hypervisor running. On top of hypervisor, you're running a virtual machine, which is basically the guest operating system. And then your application is bundled in that guest operating system. Now, the fact, it's a full-blown operating system. It's a full-blown CentOS, Ubuntu, Windows, whatever it is. And then it is sitting on top of a host operating system. They do communicate with each other, but that guest operating system has all the capabilities and functionalities in it to make things happen. On the right side is what is typically a container infrastructure look like. So you have your same infrastructure, cloud, on-prem, data center, laptop. On top of that, what you're running is an operating system, and you have a tiny layer of Docker engine. Now, I talk about containers. And I'm not going to get into the controversy, what are the different container formats, but let me take a quick survey. Is anybody using Rocket in development or production? Okay, no hands. That's pretty much very consistent with what I've seen. So when I say containers, I pretty much mean Docker all the time, and that's pretty much what everybody means all the time as well. So I have this infrastructure layer at the bottom, then I have a Docker engine layer running on top of that, which understands what an image is going to look like, what a container is going to look like, and then my tiny image is sitting on top of that. So as I compared and contrast, if you look at Ubuntu, 1 gigabyte versus 123 as a base image, and then you install things on top of that. This is a MacBook, for example. On this MacBook, I can run VirtualBox. I can run 2, 3, depending upon which operating system I'm running, maybe 3 virtual machines. But if I want to run containers, which I do all the time, I've been able to run up to 50, 60 containers very easily. So density is a big deal when you're doing virtual machine versus containers. Now, does that mean, is it virtual machine versus containers? Not necessarily. A lot of people have made a lot of investment in terms of virtual machines. So that is a very fundamental requirement. So it's not virtual machine versus containers. So if you look at this, on the left-hand side, again, you see physical server, operating system, Docker engine, and you got a bunch of your containers running on that. On the right-hand side, if you have a hypervisor, then you could run virtual machines over there. Your applications can continue to exist on the virtual machine, and then on certain virtual machines, you may choose, I'm going to install a Docker host here, and on that Docker host, I'm going to run my containers. Now, the applications from virtual machine can talk to the Docker containers and vice versa. Yes, you may have to poke firewall holes and things like that, but that's certainly possible. So don't think of VM versus containers. They can certainly coexist, and as a matter of fact, in all practical aspects, you will see them coexisting. Another myth I want to clarify is Docker is not a lightweight VM. It's not a virtualization technology. Don't think of this, VirtualBox or VMware is there, but they give me a full-blown operating system, and it's a lightweight VM. Docker is an application delivery technology. How you use it, it just simplifies your application delivery. Whether you are building your tools, whether you are firing up your dev environment, whether you are reducing impedance mismatch, whether you are running your databases, whether you are running your stateless containers, stateful containers, all of that, CI, CD, you name it. So Docker is an application delivery technology which really simplifies your application delivery. It doesn't create any burdens. It doesn't create any roadblocks. You see how your tools are, what the tools are. It just seamlessly blends in there, and it just simplifies the process for you, basically. So that's sort of the background, essentially. Now, over the next few minutes, actually pretty much till the end of the presentation, what I'll show is how is it, well, first of all, Couchbase is a NoSQL document database. You can store JSON documents in it. You can retrieve JSON documents in it. You can run queries on it. It's a horizontally scalable database. So what I'm going to show by end of the presentation is what is a typical classical way to create a Couchbase cluster on Amazon, and then I will start covering one by one all of these different frameworks. I was trying to show live demos, but the network connectivity is not very reliable here. So I have tested all of these. There are very clear instructions how we give it to our customers, etc. So I will give enough references in the slides that you can take a look at. So let's see, how is it that we classically create a Couchbase cluster? Well, VM1, VM2, VM3, you fire up 3 virtual machines. Amazon doesn't matter, it runs on a variety of operating systems, the usual ones. Then on each VM, you will typically you will install one Couchbase server, because it's a database, you want to make sure it's created in a cluster. And we always recommend to have a 3-node cluster as a minimum to make sure there is primary document, and for the primary, you have a replica document because it takes care of all of that for you. Just for convenience and in order to make sure that the cluster can be created, Couchbase is a horizontal architecture. Each node is exactly identical, exactly alike. There is no master-slave concept here. But just to kind of simplify the automation part of it, we pick any one node as a startup node. This is going to be my startup node. And then the other 2 become just the nodes. Those 2 nodes need to be added to the startup node, which basically makes a cluster here. So I'm just going to create a simple cluster. Here is my startup node. I could have picked VM2 or VM3 as a startup node, and the other 2 nodes get added to that. And once the cluster is created, it's a homogeneous cluster. You can write to any node, you can read to any node. All of that is completely automated for you. There is no single point of bottleneck here. That's the important part to understand here. And then finally, once the data is written, let's say you have a 2-node cluster, you're adding a new node over there. You want to rebalance the cluster so that the data is well spread out across, then you will rebalance the cluster. So those are the terminologies that we're going to be using when we're talking about next 4 different frameworks, and see how that's going to help us. Okay. So first thing first, the first example that I'm going to use is Docker for Docker, Docker Inc., the company itself. The typical confusion between people is, Docker Inc., does it mean the Docker container? No, Docker Inc. is the company behind the Docker container format. Docker is an open source project, but Docker Inc. has a whole bunch of products around Docker format as well. So what is the easiest and the simplest way to get started with Docker on your Mac or Windows? Well, Linux is a native technology, so you can do apt-get install, yum install, whatever your package manager is. You install Docker.io, it gives you all the CLIs, and then you can run it as a local host, and then you can start pulling containers, running containers, pulling images, all that. If you're on a Mac or a Windows, Docker for Mac and Windows is the definitive way to get started with it. It's a native application. It automatically updates, so they automatically push any updates to you. Earlier versions of Docker required you to install VirtualBox, so you will create a hypervisor, and then in that hypervisor will be Docker host configured for you, and then you can run containers, etc. None of that required. And how is that possible? On Mac, there is a hypervisor framework, a particular version. We'll talk about that in a second. And on Windows, there's Hyper-V VM. So it creates the X-Hive VM on Mac and Hyper-V VM on Windows, and that's where the containers are running. So from your perspective, all you're doing is downloading Docker for Mac or Windows, DMG or an exe file. You fire it up, and it's configured. It's seamlessly available as on the local host for you. Very nice integration with file system, volume mounting, and things like that. And most of my experience has been around Docker for Mac. It's really seamless. How do you get started? Go to docker.com/getdocker. It does require a specific version, so you do need 10.10 plus for Mac and Windows 10 64-bit. If you don't have that operating system, sure, go ahead. Go for Docker Toolbox, which is again a loosely coupled set of tools that are available, which will allow you to get started. Now you've done your development. You have built your application. Your application typically consists of multiple containers or multiple images, and those need to talk to each other. You've done the development deployment on a single host, which is okay, but single host is a single point of failure. That's a fundamental flaw for distributed architecture. So then you say, okay, I want to take it to multi-host. That's where Docker for AWS is very handy. Well, Docker for AWS is nothing but Docker for AWS and Azure. Essentially, it is very seamlessly integrated with AWS CloudFormation template. So if I look at it now, on AWS, it's a CloudFormation template. So you can say, create a multi-node Docker cluster for me, and this will create the cluster for you. There will be a manager. You can have multi-managers. Then there'll be workers where the actual containers are running. The managers can be configured for running containers as well, but that's not the point here. But the point is, it's a highly available Docker, multi-host Docker cluster that can be easily provisioned using CloudFormation template. And the fun part is, once you create that Docker for AWS cluster, it is automatically into an auto-scaling group. What that means is, if a node goes down because of ASG, the node automatically comes up. So you always have that many hosts available as part of your cluster. If you are running a service in the Docker because it's integrated with ELB, depending upon the configuration that you use for service, the service is automatically exposed using Elastic Load Balancer. You can start taking snapshot of your data on EBS volumes. If you can start mounting volumes, particularly it's useful for a stateful container. Similarly on Azure, similar language over there. It's integrated with VM scale sets, load balancer, and Azure storage. Today, Docker for Mac, Docker for Azure and AWS is restricted availability. But I've been told this is going to be generally available very soon. So beta.docker.com is where you will start getting access to these tools. Essentially, end of the day, I get an email that, hey, a new version has been updated. I click on it, then I go through the CloudFormation template, and I'll show that to you in a second. This script is a key script that we're going to follow today, and which basically helps us create the Couchbase cluster. So let me kind of walk you through this script. So if I look at, essentially what I have is a Docker file. In the Docker file, I'm saying I'm inheriting from Couchbase server, which is sort of my base image. And then I'm just calling this script, which is configure node.show. And what I'm showing you is a snapshot of configure node. Well, on line 4, I fired up my Couchbase server. Line 8 through 21, essentially, what I'm doing is I'm using Couchbase REST API to configure my server, because when I'm doing this in an automated way, I don't want somebody to manually sit down, click, do all of that. I want Couchbase server to be pre-configured. I'm picking up some reasonable defaults. I'm using my REST API to configure my Couchbase server. So I'm picking memory optimized indexes. I'm loading a sample data. You can configure this anyway. I've set this up for a demo environment. So I load up some sample data as well. Then line 25 to 37 is the key because, well, line 8 to 21 is where I set up my single node, but line 25 through 37 are the key because that's where I set up my cluster. Essentially, I'm taking a few environment variables. I'm saying, is your type a startup type, a worker type? What are you? Are you going to be the first node? Are you going to be the second, third, fourth node? So that's the first variable I take. Then, once I've identified that, then I say, oh, now you are the second, third, etc. node. So tell me where the master node is running so that I can add myself to the master node and then form a cluster. once again, I want to clarify, I'm using the terminology master worker, but in no sense it's a master slave architecture. So don't get confused by that. It's just master is the wrong terminology probably I chose. Should have been more like a first node or a bootstrap node essentially. So I take on line 25, if you see, I'm saying type equals worker. If it's your worker, then I look at Couchbase master and I add myself to that. And again, I'm using the Couchbase CLI over there to add myself to the cluster. So this is sort of a fundamental image, Docker image that I'm going to be using throughout the talk on how I'm going to create a cluster. The way I create a cluster is a little bit different in each of the environments. So how do I create a cluster using Docker for AWS? Well, in Docker 1.12, they introduced the concept of service. You can fire up a service. You can say Docker service create. You can give it service a name. You can give an image, and you can give the number of replicas. And then Docker will make sure the host, or the Docker for AWS will make sure that many replicas are running at a given point of time. So that's one of the fundamental new features as part of Docker 1.12. I can also say, oh, by the way, expose a certain port, 8091, and then that port 8091 is exposed as my ingress load balancer using ELB available to me. Now, in this case, I'm saying the name is Couchbase master because somewhere I want access to the web console. The Couchbase is a web console. Somewhere I want access to web console. So I just poke the hole here on port 8091, which is -p 809191. And then my web console is accessible over there. The second service that I start here is I'm saying Docker service create. Now this is a Couchbase worker service, single replica. I'm saying type is equal to worker, and I'm saying Couchbase master pointing to the master service here, and the exact same image. And the final command that I knew, once I've done the master service and the worker service, the container started by worker service has added itself to the node here. It's a 2-node cluster. Now I can use standard Docker commands. I can say Docker service scale Couchbase worker 3. So now 3 instances of worker are running and 1 of master are running. It's a 4-node cluster. Okay, so let's walk through this. So exact same image. So master and worker is only for the namesake. So exact same image, no master slave concept otherwise. One is a master, the other one is a worker. The worker points to where the master is running so that the cluster can be created. They're both running in an overlay network. Docker has concept of a bridge network, which is confined to a host, or you can have an overlay network where the containers can talk across the host. So I've created a host overlay network here. And then finally, of course, I'm scaling it. So using Docker native commands, I can scale my cluster up and down, and that'll work. So if I show this to you in a schematic here, I have a startup service. I create a Docker startup service. Then I create a Docker node service. And the number of replicas, as I said, are 3 over there. And these are all same consistent image. So it's a very consistent horizontally scalable architecture. And that creates me a Couchbase cluster here, essentially. Okay, a complete video on how this was done. How to create a how to use the CloudFormation template to create Docker cluster, and how to create a Couchbase cluster in Docker for AWS is explained on the video link over here. And these slides are, by the way, available. I'll share the link at the end of the presentation. Now, Docker for AWS is good, but I want to see some monitoring. I want to see some, scalability aspect. Do I need to really go with the command line capabilities? Well, that's where Docker Data Center, which is a commercial product by Docker Inc., the company, is useful. Docker Data Center consists of 3 components primarily. First of all, it consists of commercially supported Docker engine. Then it consists of Docker Trusted Registry, which is running as part of the DDC or Docker Data Center. So in case you are changing your images, you're doing CI, CD, all the fun stuff, you can push your images to the Docker Trusted Registry. And last but not the least, it consists of DUCP or Docker Universal Control Plane, which allows you to scale your containers. It shows all the monitoring charts, all the fancy dashboard, everything. Now, the most recent version of this was released about 2 days ago, so I did not get a chance to try out DUCP. We're still recovering from the elections. But DUCP, most recent version is available, which allows you to create services. And so that block should be coming out soon. Now, when you're running a stateful container, a typical question is, containers are like diapers. You shit in them, you throw them, you bring a new one on. But if it's a stateful container, I want to maintain that shit, because that's my state. So how do I maintain that shit? This is how you maintain your shit. Well, there are a few ways where we help our customers. Well, first of all is per container storage. When you fire up a container, there is a volume available to it. So by default, Couchbase writes to OPT Couchbase var, so the data gets stored over there. That's cool. But if my container dies, that volume stays, but is inaccessible to the next container because it's a stateful container. So I want the state to be accessible. So this is okay for testing. It's okay to begin with. When you're doing per container storage. The other option is when you can do explicit host directory mapping. So when we run clusters in a VM environment, we tell our customers, okay, have your Couchbase node or Couchbase VM to write it into the SSD, which is attached to the node itself. So this would work well for that. So I can say, okay, I'm firing up a container, have a directory in the host, map your OPT Couchbase var where the container writes to a directory on the host. Now, if that container dies up, if that container dies and a new container comes up, you can do the exact same directory mapping, and the data is still accessible to you. So the container can keep dying. All you have done is you have extracted the state out of the container into the host directory. Another option that we have seen customers using is they would use a shared network file system. So you can set up your Ceph, GlusterFS, or network file system, and instead of a host, because then host becomes a single point of failure, you can start putting it on those shared network file system. So that way your data is across on a network. If a host dies, you can bring up a container, which all these different orchestration frameworks do. You can bring up a different container on a different host, and you can do the volume mapping. There's a lot of work, though. That's where Docker volume plugins come in. Things like Flocker, Portworx, those are the tools that we have seen. So essentially, Docker has this mechanism of Docker volume plugins, which anybody can write, okay, we know how to manage volumes, so let us do the container-based storage for you, and you just worry about the state of your container. Now, what it does is, essentially, if you're using Flocker or Portworx or any of these plugins, once you install the plugin, you create a EBS volume, and then you can say this EBS volume is now attached to this container. So if a container dies and if a container comes up on a different host, your volume will follow the container across different hosts. That's pretty cool because that's exactly what we are looking for ideally. And with this, you can create your snapshots of your volumes on EBS, GCE, persistent disk, you name it. The whole variety of flavors are available. Dell EMC has a product called or a plugin called as Rexray, which I just found out this morning. So this is one of the blogs that I've been meaning to do. The first two options are very clearly covered in the blog over here, but the next two options will be getting covered soon in my blog. So just stay tuned on that. So that's sort of how Docker, we help migrate our clients to clusters from Amazon to Docker for AWS. Let's talk a little bit about Kubernetes then. Well, in Kubernetes, we know the concept of Docker is there. So when Kubernetes is container agnostic platform, by a show of the hand, we saw nobody is using Rocket here in any sense. So even though Kubernetes is container agnostic, but Docker is still the prominent platform. So let's assume that there is a Docker host over there. The basic concept in Kubernetes is of a pod. Well, pod is the smallest deployable unit in Kubernetes, which is co-located group of containers that share a namespace, IP, storage, all of that together. The containers within a pod can talk to each other as if they are on a local host, but outside they have to use an IP address for the pod. Well, actually, the containers outside the pod cannot talk to containers in a different pod. The pods can talk to each other. Then there is a concept of a replica set. A replica set says, okay, you want to run, it's basically like a cookie cutter recipe. Replica set says you want to run 4 instances of this pod. I will make sure 4 instances of the pod are running. If a new instance if a 5th instance of the pod comes up, I'll kill one of them. If 3 are running, for instance, if 1 dies, I'll make sure 4 are running at any given point of time. One of the things about Kubernetes is each concept, each resource in Kubernetes is given an IP address. But pod particularly is ephemeral. If a pod is running on a host, if a pod dies, it comes up on a different host, it may be assigned a different IP address. And typically when you are connecting from your application to a database, you need a stable name. You can't rely upon an IP address. So that's where the concept of service comes in. Service basically is a stable name to a bunch of pods or whatever number of pods that you want to connect to. And it also acts as a load balancer for your different pods. So the typical way, Kubernetes is an opinionated framework, but it's sometimes difficult to understand. But the typical way you deploy applications in Kubernetes is you will have a replication controller or a replica set where you can scale the number of containers in them. And then that replication controller will be front-ended by a service because that's the logical name that you can refer to, which is also doing the load balancing for you. The last bit of piece here to understand is how are these pods in a service are connected. Well, it's a very loosely coupled mechanism. Each pod is given a label, and a service is looking for those labels. And those labels are stored in a etcd, which is a distributed watchable registry. So a new pod comes up, it says, hey, I have got this label. Service says, hey, this is the selector that I'm looking for, and the pod becomes part of a service. So it's very loosely coupled, very efficient programming. Some other concepts in Kubernetes is, of course, there's a concept of a node, which is a machine or a VM in the cluster. In terms of node, there is a master node, which is sort of the central control plane, which provides a unified view of the cluster, which is sort of your single point of administration. In Kubernetes 1.4.5, which was released, I think, a couple of weeks back or 3 weeks back, there is still the concept of a single master. And I'll talk about that, how to get around that. But Kubernetes 1.4.5 still has the concept of a single master, which is a single point of failure. There are hacks available, but then, again, those are hacks. And then there is worker node. Worker node is where all sorts of containers are running. Unlike Docker for AWS, where containers can run on manager or worker, here containers only run on the worker. So there's a bit of a difference in terminology as well. There is on the worker node, there is kubelet. Kubelet is sort of a node agent. Well, let's take a look at the broader architecture. So here, I have a master. Master has an API server. API server essentially is, which is listening for all the API requests coming in, REST API coming in. And it says, okay, you want to create a resource, update a resource, delete a resource, you want to CRUD a resource, whatever you want to do, send me a REST request, I'm going to process it, and I'm going to take care of it. You want to create a replication controller, I got a controller manager that will do that for you. I want to schedule a container on anywhere on the host, I got a scheduler for that. And where are all the labels getting stored? etcd. So those are sort of key components of your master. kubectl is your main entry point to Kubernetes, which is your CLI. Using that CLI, you say, I'm going to CRUD my resources. Pretty much the entire application development, deployment, update process in Kubernetes is about kubectling your resources. So kubectl makes a call to the master, which essentially goes to the API server. Then you got a couple of workers over here. They're exactly alike. The API server, in turn, talks to the kubelet to make sure that once the scheduler has figured out, oh, this is where the pods need to be scheduled. So I'm going to give the task to the kubelet to do the scheduler. The kubelet will actually schedule the pod on the host. And there's a proxy on each host as well, which says, okay, once a request comes into me, I know which pods are running, and I can act as a load balancer for them. On the far right, what you see is your typical application. Your client makes a request to the load balancer. This load balancer could be part of your ELB or Kubernetes itself as service is exposed. So it knows the internal details of the proxy, so the request goes to it. And this is sort of what your Kubernetes cluster is. So that's sort of a broader architecture view of what Kubernetes architecture looks like. Now let's see the Couchbase cluster that we created in Amazon, how could that be translated in this Kubernetes architecture? Well, before that, just the way we have Docker for Mac and Docker for AWS, the easy way to start it, and this was introduced pretty recently only, is called as Minikube. Minikube, it allows you to run a single node cluster in a VM. You can download the Kubernetes distribution from github.com/Kubernetes releases. But that's like a 1 gigabyte download. Then it uploads that to S3 if you're running on Amazon. So it's a bit of a nightmare. Well, it works okay if you're on a home or a work network, but particularly for somebody like me at a conference or a plain network, you can't rely upon that. Well, that's where Minikube is very helpful. Minikube, you download it locally. It runs a single node cluster in a VM, very similar to Docker for Mac and Windows. It is actually targeted for local development. You download this exe. You can say Minikube start, stop. You can even configure your Docker CLI to talk to the Docker host running in the Minikube itself. So that's pretty cool. But it does require kubectl CLI. So you need to download the kubectl CLI because it's just one exe that you get essentially. But with kubectl and Minikube, you can pretty much do all of your local development very easily in an offline mode. And I talked about this, how to get started with kubectl, Minikube on the blog that is mentioned over here. Now, as I talked, if you download the Kubernetes distribution from Kubernetes releases, GitHub, that's a single master, which is single point of failure. There are hacks, but those are again hacks. I found out about this project called as COPS, or Kubernetes Operations. This allows you to run multi-master Kubernetes. Now that is cool. Docker had this concept for a while. Finally, Kubernetes got their hand around it, and now they can run in an environment where you can set up multiple masters, so that there is not a single point of failure. Now, just the way kubectl is for the resources or your applications in Kubernetes, think of COPS as kubectl for clusters. So with COPS, you can easily create and manage your clusters. Now, it is still an external tool. I'm only waiting when this COPS is going to be integrated as part of the Kubernetes release itself. So that's something to keep in mind. Now, the way we create applications in Kubernetes, we pretty much give it a resource configuration file that create my replication controller, here is a configuration file. Create my service, here is a configuration file. So here are my configuration files. So on the left is what you see is my master configuration file. In the middle is my worker configuration file. And on the right is what I'm showing is a similar command that I did for firing up my Couchbase cluster, or rather scaling up my Couchbase cluster. So first of all, a different image here, Arun Gupta /Couchbase : Kates. So I'm using a different image here, although I could have used the same image. My goal is to actually bring it down to a single image where all the orchestration framework should behave exactly the same. And I'm pretty close to that. So for the master and the worker, we are using exactly the same image. The left, as I said, is the master. Type is the variable that we are looking at it. On the right, type is the worker. So those are the environment variables that are being passed. On the left, if you look at the configuration file, on line 22, there is a separator. What it says is you can create two resources. The first one is the replication controller, which is identified by line 2. And then the second one, which is after the separator, is a service, which is identified by line 24. So you're saying, in this one configuration file, create a replication controller, create a service, and then you have defined the selector patterns so that any pods that are created by that replication controller become part of this service. So I create my master service, and on the right, on the middle, you see where I'm saying, what is my Couchbase master? It is pointing back to that service. Okay? And then finally, the service of the master is exposed using type load balancer. And this is where it is automatically integrated with ELB, and the service will be exposed for me automatically. So how do we do Couchbase in Kubernetes? Again, a very similar recipe. I have a startup replication controller. I have a node replication controller. Every time a node comes up, it looks at the environment variables. Oh, type equals to master, type equals worker. If type master, then just startup, single instance. Oh, type worker, let me go into the script and see, oh, type is worker. Tell me what the Couchbase master is. I'm going to use the Couchbase CLI to add myself to the Couchbase master, and then it becomes a cluster. So exact same image, so it's a homogeneous architecture, and then that gives me my Couchbase cluster. Okay. This is a dashboard that is available in the standard Minikube and Kubernetes distribution. It's a dashboard. Basically, all it says is, what is my CPU usage history, memory usage history. In the middle, it shows that I got 2 replication controllers, and on the bottom, it shows how many pods I have created. So this fancy dashboard comes in very handy. One thing I couldn't do, as I mentioned earlier, the Docker data center, I couldn't get the dashboard up and running, and that's sort of my next thing on my list to do. How do you store data for a stateful container in Kubernetes? That's the concept of persistent volume. Well, the idea is you provision a network storage, EBS, persistent disk, wherever you want to do. Then you create a persistent volume claim. You can have one big persistent volume. Then you can claim, I want 1 gigabyte or 2 gigabyte or 5 gigabyte, whatever. You make a claim. and then you use that claim in one of the configuration files. So that's where, that's where and how you use persistent volumes in Kubernetes, and that's sort of what our customers are using, for example. So if I can show you here, you're seeing how a Kubernetes cluster, the 3 nodes, 1 master, 2 worker, big yellow boxes, are created on Amazon Web Services. I could have data stored on the local host, but again, that becomes a single point of failure. So what I say is, okay, create a persistent volume on EBS. The important part is the node, that means where the container is running, and the EBS should be on the same region and availability zone. It cannot be across availability zones. So the container and the EBS volume has to be in the same region is AZ. So now if a container dies on one particular host and it comes up on a different host, it is automatically mapped for you. The volume or the data is carried across container restarts across hosts. So that's kind of pretty cool. A new concept that was introduced in Kubernetes is called as pet set, which was in 1.3. Now each resource that is introduced in Kubernetes has a version. It is a V1 version or a beta version or an alpha version. Alpha version basically means it's just brand new introduced. It can break backward compatibility. They can change the definition. So pet set is an alpha resource introduced in 1.3. But essentially, it allows you to run stateful pods. Okay, a pet set has 0 to n-1 pets. This is where the analogy between pet and cattle comes in. A cattle is, you chop one cattle. If the cattle dies, you bring one more cattle. Pet needs a little bit more care and love, and that's sort of what the analogy here is. If it's a stateful pet, if it's a stateful container, it needs a little bit of more time and care and love. So a pet set has 0 to n-1 pets. More importantly, each pet has a deterministic name. So you can say, hey, I want to fire up a 5-node Couchbase cluster. You can say, okay, give me the name as Couchbase-0-1-2-3-4. So 0 to n-1, you got all those names. And now you don't have to rely upon master, server, and stuff like that, master, worker. You can just say, I know the first node that's going to come up is always going to be Couchbase-0, no matter what. And that's the name that you can rely upon. So that's the concept that you need to play with a little bit. Each pet has at most 1 pod, and each pet set can have 1 pet with a given identity. Now, I've tried this one on using Google Cloud and Kubernetes. And so the idea is, if you fire up a new pet set, or you say, pet set, create 1 more pet, it'll automatically provision the disk for you on a GCE persistent disk, for example. And those things can be easily configured. Now, the concepts that we learned in Kubernetes, because Red Hat has an OpenShift platform, it is actually built using Docker and OpenShift, Docker and Kubernetes. So those concepts exactly apply to OpenShift as well. But what is OpenShift? Well, OpenShift is Red Hat's open source PaaS platform. And the way it works is all these communities on the left-hand side you see, they feed into OpenShift origin. That's sort of the point of entry in a very classical Red Hat way. And then it goes to either OpenShift Online, or on the top, which is, the name is changed. It's not OpenShift Enterprise anymore, it's OpenShift Container Platform. So, but that's where it goes out. So what does OpenShift Container Platform comes of? Well, you have a container host. Again, that's another classic example where Red Hat stays away from using the terminology Docker. It's Docker host for all practical purposes. There is a container host. On top of that, you have a container API. They have done an abstraction so that they are agnostic to the underlying container format. Today is Docker API. Tomorrow it could be OCI, Creo, pick your favorite container format. But container API and container host in case of Docker can be kind of submerged in one. And then there is a container orchestration and management, which in case of OpenShift is provided by Kubernetes. And then they have a bunch of services on top of that. Now, OpenShift is a beautiful platform if you are looking at building your application. You want CI, CD, you want that scalability, you want that integration with tool sets, all of that. So it provides a lot of value. But from Couchbase perspective, because Couchbase is sort of a hidden, boring piece of your application, it can just stay there. So your strategies for Kubernetes would apply exactly here as is. Couchbase is the only NoSQL document database which is primed for OpenShift. So that means you can go to OpenShift Hub and you can say, okay, we have done the certification here, click on it, deploy a Couchbase instance. I applied the exact same strategies, and this is sort of how I got Couchbase OpenShift dashboard, which says, okay, 1 pod running, 3 pod running, and these are configured together in a cluster. All right, last but not the least framework that I want to talk about is Mesos. Well, Mesos is an open source cluster manager from UC Berkeley. It literally started as a PhD project, I think about 2009 timeframe. What it does is it provides resource isolation, saying, okay, I want to run a resource, completely box it, and then don't let others integrate with it. That's how it started. It started before containers was created, before the concept of containers became hip. So that's sort of the basic idea, but it allows you to share across distributed applications, those resource isolation. Another cool concept about Mesos is, you can have a bunch of nodes put together, and then you can run a whole variety of resources over there. I'll explain how that works in a second. So for example, you could run Hadoop, Spark, Jenkins, Couchbase, whatever your big data platform is, whatever your small data platform is. Now, you're not restricted to running only containers. It allows you to run a variety of other frameworks as well. So that's sort of an added plus point for Mesos in that sense. It provides cluster monitoring baked in. It also, the task isolation is done via Linux containers here. Yeah. So let's take a look at the architecture of Mesos a little bit. Well, the first thing typically, I have created Mesos clusters with hand, ground up, on a brand new CentOS VM, so kind of feel the pain for it a little bit. You got to create a zookeeper quorum because that's where your managers need to be registered. So you can have a single manager or you can have multiple managers. There is one primary and everything else is secondary. Then you can configure a bunch of slaves over there. You can say, okay, I want to have a slave. Each slave has a whole bunch of resources, CPU resources, memory resources, all of that. Those resources are essentially provided as a total set of resources that are available at master. Now, you can have a variety of frameworks that could run on these slave. Master, again, is a central point of administration, but the actual frameworks are running on the slave itself. So I could say, take Marathon as a framework. Marathon is a framework, by the way, which enables running Docker containers in Mesos. You can run Kubernetes as a framework, but I found out recently only that Mesos is pulling out Kubernetes support. I've seen that pull request coming through. You can run Spark, you can run Hadoop, as a native platform, as opposed to running them as a container by itself. So those are essentially, those frameworks have corresponding executors. You run the executors. Within the executor, you have a bunch of tasks. So for example, I could say, oh, on this node, I want to run a Marathon executor. And in that Marathon executor, I want to run a task. And from your perspective, that task really becomes a Docker container. So that's sort of, you're going to think about it. Now, Mesos is good. If you have to fire up a cluster of Mesos by yourself, it's pretty painful. And it's very hard to manage and maintain. Well, that's where a company like Mesosphere is pretty gung-ho about it. They have created an open source offering here, DCIOS, or Distributed Computer Operating System, essentially. It's a very logical complement for Mesos. You don't have to set up master, slave, zookeeper quorum. None of that has to be done. Otherwise, if you are doing this by yourself, it becomes pretty painful. The DCIOS includes a fantastic UI itself, very rich, very, very powerful UI. If you're setting up a Mesos cluster by yourself, then you have to install Marathon and Chronos and whatever services you want to install or frameworks you want to install. You don't need to do that. Along with DCIOS, it also gives you advanced security and enterprise support. So just like all other, Docker for AWS, well, Kubernetes doesn't have a CloudFormation template. OpenShift has a CloudFormation template. So just like OpenShift and Docker for AWS, DCIOS can be fired up as a CloudFormation template as well. And then when you fire up as a CloudFormation template, once again, it takes a configuration file. The configuration file formats are not drastically different, but they all have their subtle nuances. Oh, we take this. Oh, this is how it reflects value in the dashboard. So let's take a look. This is my master configuration file, a little too long, about 49 lines. But the key part that I want to highlight here is Here, I'm using Arun Gupta /Couchbase : swarm image. First of all, I didn't have to create a new image for DCIOS. I could use a swarm image. So my only goal is now to look at my Kubernetes image and swarm image and merge them into one. And then it's a single image that can be deployed on the cluster across the different container frameworks. So it can be done. Then I'm saying environment type, and it takes a JSON file as a configuration, so which is all right. Then you say type equals to master. In this case, I want to expose that single service out on the load balancer so that I can access my Couchbase web console where I can start seeing how the cluster is created. I can fire some queries and stuff like that. Then I'm also creating an overlay network. By default, it has a bridge and a host network, which doesn't allow the containers to connect to each other or talk to each other. Or if you create a bridge network, so this was the challenge that I was facing. By default, it uses bridge network. If you use a bridge network, then each container is assigned exactly the same IP address. It is protected, so that means that if the containers try to talk to each other, they get confused over there. So I had to create an overlay network here. Once I create an overlay network, which is a default network that exists in DCIOS, I could actually make the containers talk to each other. And last but not the least, a new nuance here is, when you look at the DCIOS dashboard, it has a means by which you can check, is the container running healthy or not? Now, Couchbase has a REST API, as we saw that earlier in the configuration file. So all I'm doing here is, by the way, go check /pools, and if /pools give you 200, then I'm golden. And that's how it reports the healthy status of my Couchbase server in DCIOS. This is my worker configuration file, about 63 lines long. The key part I want to highlight here is exactly same image, Arun Gupta Couchbase : swarm. The type is worker, and in terms of Couchbase master, I'm actually pointing to the service that is created from my master. And that service name is automatically generated for me. It's a fixed name. And that is done using virtual IPs behind the scenes. But from my perspective, I'm getting a logical name that I can bind to, and then behind the scene, it'll manage that. So how do we do Couchbase in DCIOS? Well, very similar thing. I have a startup service. I have a node service. And as the node service comes up, it goes through the configuration file. What is your type? Master, worker. If you're worker, then I'm going to add myself to the cluster. And how will I add? Because I know my master service. And I'm going to go add it to the cluster, and I become a multi-node cluster. Same Couchbase image, and that gives my cluster here. And once again, the entire description on how do I create this cluster are explained on my GitHub repo here. This is sort of how the DCIOS dashboard looks like. It's pretty fancy, I think. The key part that you want to look at is, if you look on the top left, it says 18 of 24 shares have been used. Remember, we had multiple slaves at the bottom. Those multiple slaves, whatever number of CPUs are allocated to each of those are put together as a unified set of CPU shares that are available. Now, if I'm running multiple Couchbase containers, and each container is, say, for example, taking 4 CPUs here, so that's 4 into 4, 16, and 2 are required by the master. So that's about 18 CPUs gone already. Then in the middle, what you're seeing is a memory allocation. So you're saying, okay, the total amount of memory available in all the slaves is 82 gigabytes, 17 gigabyte is used. And you can alter that, you can change that at any point of time. Similarly, disk allocation. Then on the bottom left, where you're seeing is Couchbase startup service, Couchbase worker service. Those are the 2 services that are reporting healthy because of that /pools REST URI that we used. And the middle, on the bottom middle, it's showing the number of tasks that are running. And then on the right are some health component health status. If you dig a little bit deeper into the DCIOS UI, you will start seeing, okay, here are all my services running. From my perspective, I'm running a Marathon load balancer as well, because I want to expose that one service as part of the load balancer. So it shows that. And then the Couchbase startup and the worker service that are available, which are reporting as a status healthy, which is pretty cool. In DCIOS, again, I have the concept of persistent volumes. So you can have local volumes. So if you use a local volume, you need to define it explicitly, in which case the tasks, or the container in our case, are pinned to the node. What that means is, if a container goes down, it comes back on the same node, and it is automatically attached to the volume. So if you scale the app or scale the number of containers, then the new volumes are automatically created for you. Or you can use external volumes as well, where you can say, I'm going to attach to the EBS volume. So in which case, the task can run on any host. The only problem with that is apps can only be scaled to a single instance, and that's sort of a limitation that I found out literally yesterday. So I need to play with this a little bit more on how to work around this. So we looked at the different, how to migrate a Couchbase cluster running on Amazon on these 4 different container frameworks. We saw the recipes, what to do, what not to do, how to persist the data. What are my typical virtual machine concerns? How do I back up a container? Well, once again, as I said, if you are running a stateful container, get the state out of the container, store it in the volume. Let the container die, let the container come back up again. You need to be worried about backing up that volume. If it's in an EBS, take snapshot, whatever you want to do. So you're not really backing up the container itself, you're backing up the snapshot. If you're running Couchbase like a container, a stateful container where there's part of the information in the memory, sure, you will lose that. But then the next hit, it will read the information back up again. How do I patch a container? Well, containers are again stateless. There is no patching of the container per se. So let's say you're running a 5-node or a 6-node Couchbase cluster, which is running 4.5.0 version, which is the version released earlier this year. And now you want to upgrade it to 4.5.1. So then you will do a rolling update. So for example, in Docker, there is a concept of a rolling update. Then you can say, take this 6-node cluster, update 2 nodes at a given point of time, wait for a specified seconds, let the cluster kind of settle down, then the next 2 nodes, and then the next 2 nodes, and so on and so forth. So similarly, Kubernetes has this concept of a rolling update. So what you do is you do a rolling update of the container and still make sure your container state is outside in the volume. Here is a book that I found very useful. Docker has released the book Docker for the Virtualization Admin. So the link is at the top on the browser link, as a matter of fact. So take a look at this book. This book really explains what is it that you need to do if you are an administrator and you want to understand how is Docker and VM really play nice with each other. Last but not the least, these are some of the references. So Docker, for anything Docker, would be docker.io or docs.docker.com. For Kubernetes, OpenShift, and DCIOS, they have their corresponding I/O sites. If you want to understand how to run Couchbase on a variety of containers, all of these recipes are linked from Couchbase.containers. Well, let's not say all. This website is about a couple of weeks old. I'll make sure I update that website tonight. But all the recipes will be listed over there if you want to run Couchbase and containers. So anything that I talked about, it should be available over there. And that's the end of it. We have about 3 minutes if there are any questions. And if there are none and you guys are ready for beer, we can head out as well. All right.